Hey guys, Mr. Backerberg here. In this video, we're going to look at some basic sine and cosine waves. So as we're looking at a sine graph, this picture is the function f of x equals the sine of x. Now, if we were going to type this into our calculator, to get this picture, we would need to make sure that we're in radian mode. And we can actually tell a lot about our sine function by looking at the graph. Some of the things that we focused on this year are things like the domain and the range. So as far as the domain of a sine graph, this wave is going to continue out to the left and it's going to continue out to the right. So we would say the domain of our function runs from negative infinity up to positive infinity. For the range of our graph, range refers to the y value, so how high and how low our graph goes. The highest point on my graph is at a y value of 1. And the lowest point on my graph is at a y value of -1. So the range for our graph is going to run from -1 up to +1, including all of those values in between. Now this graph is continuous, meaning that we can draw out this entire wave without needing to pick up our pencil. This does have symmetry. It's actually symmetric with the origin. And that means that this is an odd function. Now this graph is both bounded above and below, since there's a highest point that our graph never ever goes above, and there's a lowest point that our graph never ever goes below. That highest point on our graph is at 1, so that's the absolute maximum of our graph. And as far as the absolute minimum, the lowest point on our graph is at -1. Now, a sine function is periodic, meaning that it's going to repeat itself. Like if we look at this wave over here, we're at a height of 1. But if we look a little bit further down the line at this bump in our graph right here, it's also at 1. And the distance between these 2 points is the period. And sine functions are periodic with a period of 2 pi. And that's because if we think about a unit circle, every 2 pi accounts for 1 full rotation. And if we make 1 full rotation all the way around, then we're right back where we started. Now, one last thing I want you to notice about this graph is its basic shape. If we start in the middle looking at the origin, that's kind of in the middle of a wave. And as we work our way out to the right, we're going up until we hit that maximum point. Then we have to come back down. We cross through the x-axis again before we hit our minimum point. And then our graph turns and starts to head back up and hits the x-axis one more time. Now, if we work our way to the left, the reverse is happening. So our graph is going down. We hit the minimum point. After we hit that minimum point, our graph has to come back up, and it's going to cross through the x-axis again. Then we're going to hit a maximum point on our wave, and then our graph has to turn and start to come back down before it hits the x-axis one more time. Now, as we're comparing the sine function to a cosine function, there's going to be a lot of similarities, but the shape of the graph will be a little bit different. So now we've got a new graph to look at, and this is for a cosine function. So this is the function f of x equals the cosine of x. And just like the sine, to be able to graph this one out, our calculator needs to be in radian mode. Now, there are a lot of similarities between a sine graph and a cosine graph. They have that same basic wave shape. As far as the domain goes, our graph would continue left and it would continue right. So we would say the domain runs from negative infinity up to positive infinity. And for the range, if we look at the highest point on our graph, our highest point is at +1 and our lowest point is down at -1. So the range runs from -1 up to +1. This graph is also continuous. Now, as far as symmetry goes, this graph is symmetric to the y-axis. And that makes this an even function. Now, this graph is also bounded above and below. And our absolute maximum, the highest point on our graph, occurs at 1. And we also have an absolute minimum at -1. Now, similar to our sine function, this cosine function is also periodic, meaning that our graph is going to repeat itself. So if we look here where our graph is at -1, later on our graph hits -1 again, and the distance between those is the period. And just like a sine function, a cosine function is periodic with a period of 2 pi. Now, if we focus kind of on the center of our graph and work our way out like we did with the sine function, as we look at where the cosine is starting, it's actually starting at the top of a wave. So as we work our way out to the right, it has to go down so that it can cross through the x-axis. Then it hits a minimum point and turns and comes back up, hits the x-axis again, and then as we're working our way up, eventually we would hit a maximum point again. And similar things are happening as we work our way out to the left. So we're starting at the top of the wave, but we have to come down and hit the x-axis. Then we hit the minimum point on our wave, turn and head back up and hit the x-axis. And then this graph, as it's going up, eventually it's going to hit that maximum point again. And because these sine and cosine functions are periodic, even though we're looking at just a small chunk of these waves, because they're periodic, they would continue their behavior as we work our way out to the right infinitely, and as we work our way out to the left infinitely. That's going to be it for this video. Thanks for watching.